How do I troubleshoot Cryptic MATLAB Simulink errors? Imagine spending hours building a model in MATLAB Simulink only to face an error message that makes no sense. It can be frustrating, but don't worry. There are clear steps to solve these tricky issues. MATLAB Simulink is a powerful tool used in electrical engineering for creating models of circuits and systems. When errors pop up, they can be vague or confusing, especially if they relate to solver problems or block connections. The first thing to do is understand the type of error you are facing. Sometimes, errors come from simple mistakes like missing connections or incorrect block parameters. Other times, they are deeper, involving solver settings or physical inconsistencies. Start by checking your model's connections carefully. Make sure all electrical components like resistors, capacitors, and sources are correctly wired. Missing ground nodes or incorrect polarities are common causes of errors. Next, look at the specific blocks highlighted in the error message. Verify their parameters, units, values, and settings. In Simulink, incompatible units between blocks can cause simulation failures. Pay special attention to converter blocks that switch between physical signals and Simulink signals, as mismatched units here often cause issues. If your model is complex, try simplifying it. Break it into smaller parts and test each one separately. For example, test just a power source with a resistor before adding more components. This helps you find exactly where the error begins. MATLAB Simulink offers built-in tools like the Model Advisor and Diagnostic Viewer. Use these to automatically check your model for common issues. The Model Advisor can flag unconnected blocks or configuration problems. The Diagnostic Viewer shows detailed messages that can guide you to the root cause. Solver settings are also important. Electrical systems often involve both fast and slow dynamics, which can challenge the solver. If your simulation fails or produces strange results, try switching from a variable step solver to a fixed step one. For stiff systems, solvers like ODE15s or ODE23T are more stable. Adjust the step size to see if that improves the simulation. Physical consistency is key in models using Simscape. Ensure your connections make sense physically. For example, avoid connecting to voltage sources directly in parallel without impedance, as this can cause solver errors. Check for unconnected nodes or floating components that can lead to singular matrices. If you are still stuck, community forums like MATLAB Central are great resources. Many electrical engineers share solutions for common cryptic errors. Posting a minimal version of your model along with the exact error message often gets you helpful advice. Troubleshooting these errors is essential for reliable simulations in electrical engineering projects. Whether you are working on power systems, motor drives, or renewable energy models, resolving these issues keeps your work on track. Remember to verify all connections and parameters, simplify your model, use diagnostic tools, adjust solver settings, and check physical consistency. If needed, seek help from the MATLAB community. Following these steps will help you quickly identify and fix Cryptic MATLAB Simulink errors, making your modeling process smoother and more productive.